Hey guys, now comes the most important mechanical components for building this trim box. That of course is the wheels. But first, for anyone who's just coming in, there's a whole playlist of videos detailing how we got to this point, so you can check all of that out in the link in the description below. Now there are 3 wheels in this design, one for each axis of trim. The largest is for pitch, the medium-sized one is for roll, and the smallest one is for yaw. Let's take a closer look at the pitch trim wheel. Pitch is by far the most frequently used axis, and is the axis that demands the highest precision. In fact, some planes dispense with roll and yaw trim and only have it in the pitch. So it should be no surprise that pitch gets the biggest wheel. This wheel is actually a 2-part assembly. The pieces are fastened together by 8 screws around the perimeter. At the center, there's a threaded insert and a set screw to keep the wheel firmly in place, as well as a window cut to give room for a small wrench. Turning the wheel over, you can see a friction reducing ring extending from the inner surface. This will sit flush against the main housing. There are also a pair of lugs. These stop over travel and direct the force from the user into the housing instead of directly into the potentiometer. Unfortunately, I haven't printed out a housing yet to mount the pitch wheel to, but I do have this little wall section. It's a simple flat surface into which the indicator needle is screwed down. The ends of the needle also function as stopping surfaces for the wheel lugs. With the wheel attached, you can see that it can be easily rotated until it hits the stops. We'll take a look at yaw and roll together, but it starts with this. This white print is the rear wall of the trim box. On the inside, there is the ADC circuit board from one of my previous videos. If you haven't seen it, please check it out. And there is also the potentiometer, which protrudes through to the outside of the wall. The next piece is a standoff plate and lug. This acts as a buffer between the yaw wheel and the main housing. It too has an elevated ring around the perimeter to reduce friction and prevent imperfections in the print surface from interfering with the yaw wheel rotation. This lug is an overtravel stop to keep excessive force off the potentiometer. The yaw wheel is a simple disc with cuts around the perimeter for extra grip. Further toward the center is a channel that the overtravel lug rides in. In the center and on the back, there is another threaded insert and set screw. The back plate is simply screwed down into the wall, and over top of that, the trim wheel can be dropped down into place. The next part is a separator plate. This prevents friction from the yaw wheel from rotating the roll wheel, and vice versa. It also has an overstop lug and a low friction ring. It has a protrusion on the bottom, which will be fastened to the main housing and prevent the whole plate from rotating freely. This last part is the roll wheel. This wheel is slightly larger than the yaw wheel. It has positive protrusions around the edge instead of negative cuts, so it can be easily distinguished from the yaw wheel just by feel alone. In the center, we have another threaded insert, and on the back, we have a trench for another overtravel lug. Returning to the back wall assembly, the separator plate just drops over the top tier potentiometer. Then over top of that, the roll wheel can be installed. And that covers the trim wheel design and assembly. The next video will be about the box floor plate, so please keep an eye out for that. Otherwise, thank you all so much for watching, and I'll see you in the next one. Goodbye for now.